So members, today we are still proceeding with chemistry, and our idea will be on what we call the moral concept. And today our emphasis is going to be on what we call the moles. Remember, moles, the teacher has told you that is simply any amount of substance that is equivalent to what we call the Avogadro's constant. Avogadro, this is the name of a scientist who made a lot of scientific investigations and discovered that this number of particles is exactly found in 1 mole of a substance. So when we equate a mole, we shall say a mole is anything equivalent to this number of particles, which we are calling Avogadro's constant. Now, without wasting time, let us go directly to how to calculate moles from mass. So our emphasis will be on how we can get moles from mass. Now, when we are calculating moles from mass, a student must be clear with what we are calling determining the molar mass. That one, that prerequisite skill, we have to be with it. Or even relative atomic masses are in line with what we call the periodic table. So we are going to continue with our lesson by basing on this question now. They say determine the number of moles in 3.2 grams of copper. Remember, from the periodic table, copper is reflected by 63.5. Others will even say 64. Now, this one we are calling relative atomic mass. Now, what we are going to do here, we are going to simply say that the 64 grams or the 63.5 grams of copper contains now one mole of copper. So if the 63.5 grams of copper contains that, then we say, what about this one given the question? What about the 3.2 grams of copper contains? So we cross multiply now. We get this one times this, then divide by this. So we shall end up getting our 3.2 times 1 divided by 63.5. And the figure we are going to get is going to be in what? In moles. And our figure here is 0.05. 0.05, you can get a calculator there and try to place it at 0.05 moles. If this one we are calling it the first principles. This one we are calling it the what? The first principles. I've applied what we call the first principles. However, you can also apply a formula. When you're applying formula, you will just come and say moles. You will say moles are equivalent to mass over the relative atomic what? Mass. If it is a formula, you can say that in formula mass. Therefore, we shall get now our 3.2 divided by our 63.5, and we shall arrive at the same what? The same answer. So it depends on what you can do, but preferably this one will help you to earn a lot of marks. This one is just to check your answer, but this one is convenient. Then from there, we can get another calculation here. They are saying calculate the number of moles of hydroxide ion is 34 grams. Now, this time now we have what we call hydroxide. The other time we had one thing was copper. This one now we have 2 elements, oxygen and hydrogen. But remember, oxygen in the periodic table is 16. And hydrogen is 1. What are we going to do? We shall find out what we call the RFM of the hydroxide. So we shall just get this 16 representing the oxygen times 1, then plus the 1 for hydrogen in the periodic table times 1. Times 1 it appears once. Times 1 here also it appears once. And then here we shall obtain 17. After obtaining 17, so we are going to say that the 17 grams of the hydroxide ions contain what? Contains 1 mole. After containing 1 mole, then again we are going to say, what about these grams which are given in the what? In the question. What about the 34 grams of the same hydroxide ions contains? And here we are going to cross multiply. We shall get our 34 times 1 out of what? 17. And our answer here is going to become 2 moles. Similarly, you can mass of say moles are equivalent to mass out of the RFM. Now therefore we are going to obtain here our 34 divided by our 17, and we are going to arrive to 2 still. It becomes 2 moles. So this is an alternative of the other one. I don't know whether you're getting, you can try many examples from there. Now this one was part A of calculating moles from mass. Then we want to see how can we get moles from molar gas volume. Members, molar gas volume at standard temperature and pressure, what you call STP. This is an abbreviation for standard temperature and pressure is always this one. In cubic centimeter, decimeter is that. Then if it is at RTP or room temperature, it is 24 decimeters. Remember, decimeter is equivalent to a liter. Or it can even be 24,000 cubic what? Centimeters. So as we have been using now the other one of RFM, this time we are going to drill more on the molar gas volume. Let us try to see one example here. The question is saying calculate. Question is saying calculate the number of moles at STP of the following, but they are giving the molar gas volume like that. So here what we are going to do now, remember this one is the volume occupied by 1 mole. As we have said here, volume occupied by 1 mole. That is at standard temperature. This is volume occupied by 1 mole at room temperature. Room temperature is around 25 degrees. Standard temperature is around 0 degrees. Or it can even be 273 kelvins, which we have not reflected here. So now when we come here, to save time, what we can do here, now we want to solve for number of moles. Don't forget that. They have given us 44 decimeters. So this time now we are going to say that the 22.4 decimeters of carbon dioxide now is occupied by 1 mole. After knowing that, then you say, what about the 44 decimeters of carbon dioxide is occupied by, then remember we are going to cross what? Cross multiply. So we are going to get the 44 times 1, that is 44 times 1, this 44 times this 1, divided by 22 point what? 0.4. And now these ones are going to become our moles. So who can guess the moles there? Now our moles there, we are going to obtain the 1.96 moles. You can get your calculator also and you press. Now when you come here, they are saying 240 cubic centimeters of hydrogen. 240 cubic centimeters of hydrogen. Then here what we are going to do, we are going to follow the same route, but remember this one is in cubic centimeters. Then what we are going to say, we are going to convert the 22.4 decimeters to cubic centimeters. Remember, molar gas volume can even be 22,400 cubic centimeters. That is at the same STP. So here, since this one is given in cubic centimeters, we are going to use this one in cubic centimeters. I've used this one in decimeters because the question had decimeters. So what I'm going to do here, I will do the same. I'll just come and say the 2240 cubic centimeters, 00 cubic centimeters, is occupied by 1 mole of what? Hydrogen. 1 mole of hydrogen. Then what about the 240 cubic centimeters is occupied by, now we cross multiply, see, we shall get this times that. So that is 20, that is 240 times 1 out of 22400. And now our answer there, we are going to arrive to 1. So remember, as we are saying that you divide 240 divided by 22400 cubic centimeters, and then we shall get our answer as 0.01 moles now. Then from there we have a question for they are saying calculate number of moles at room temperature now. So when we say room temperature, we are going to base on 24 liters. But remember, 24 liters you can also get 2400 or 24,000 cubic centimeters. The difference is that the units here they are liters, here they are cubic centimeters. So when you come here, we are going to use the same idea. We shall just come and say that if this one is in cubic centimeter, we are going to use the cubic centimeter. If it was in liters or decimeters, we use the liters or decimeters. So we come and say here that now the 2400 cubic centimeters of sulfur dioxide contain now, or is occupied. You can say contain or is occupied. So let us say is occupied. Is occupied by 1 mole. If it's occupied by 1 mole, what about now the other one given the question? What about the 200 cubic centimeters of sulfur dioxide is occupied by, so there we have 200 times 1 out of 2400. And now there we are going to obtain our answer. Place the calculator there. Our answer is going to become now 0.008 moles. Now this method and even this one which we used here, you can also use the formula. So I'm going to show you how you can apply the formula to get the same. Similarly here, we are just going to come and say that you can see they are cubic centimeters. If they are decimeters, we bring this one. But now they are cubic centimeters, so we say 24,000 cubic centimeters or 24,000 of carbon dioxide contain now. Contain is what? Contain is 1 mole. Then what about which one? The volume, the question. What about 140 cubic centimeters of the same carbon dioxide contain? Remember, we cross multiply, don't forget that. We have that times that. So we have 140 times 1 out of now the 2400, like that. And our answer, when you place your calculator, we shall obtain 0.005 moles. Remember, we are calculating moles in our lesson today. Now, if you are using formula, the formula you can just say, this formula is for people who cannot now afford this, but this one is the convenient one to earn marks. This one we just bring it just to prove the answer. This one we can just say moles are exactly equal to the volume given divided by the molar gas volume. Molar gas volume. Don't forget that. Remember molar gas volume, we have two. We have that one at STP and we have that one at RTP. So you just get the volume like this one divided by the molar gas volume, which can be at STP or it can be at RTP. You get the same answer. So if you have grasped the content properly, try to do this. This one is saying calculate the number of moles at STP of 8.5 cubic centimeters of steam, then 4 cubic centimeters of hydrogen chloride. Now this one we can say STP is very, very vital as you are calculating. So we shall begin from there with another part of the calculation.